Welcome everyone to this live session from Sky Drones. Today we are in our secret, beautiful country and location, far away from any hazards or dangers that England can have. And today we are featuring SkyLane-250 here, which has been at DroneX in Excel, London, just last week. And straight from there, aircraft is going back into the field for more flight tests. As a series of tests that we're performing this week, one of the tests we're going to carry out with this aircraft is how this aircraft is handling flights in challenging conditions, with the medical samples being inside of the aircraft. As you have seen from the previous posts on LinkedIn, as well as in real life, the aircraft at the bottom has a special compartment for transporting the medical samples that are temperature controlled and is compensating for any vibrations that flight operation can bring. So we'll walk you through how does the setting up the aircraft look like, the pre-flight checklist, the actual flight, autonomous flight, fail-safe, and landing the aircraft back. So let's get into it. To start off, we have assembled the aircraft. We have checked all of the connectors inside of the aircraft, the air link, the connectors to the wings, to the motors. Everything is working great. So now we're going to carry out final list of pre-flight checks and get flying.
And we can show you what it consists of. So basically it's powered by Airlink, the flight control system which we designed in-house, both hardware and software. So let's have a closer look in here. So that's the main unit, which is the flight computer, AI mission computer, and LTE connectivity device. So we have LTE antennas here, and these are the antennas for the standard radio to talk to the computer. There's also battery elimination circuit for the ESCs, motors, servos, radio, feeder tube, and airspeed sensor, Ethernet for connectivity, and that's it basically. In the forward compartment we have the batteries. You can do it. So it's powered by two 6S LiPo batteries. Each has the capacity of 25,000 milliamps. 6S, and this allows the aircraft to fly up to 25 minutes in hover mode with up to 2 kilos payload. And if you want to fly in fixed wing mode, it can stay airborne for up to 2 hours and 20 minutes roughly. So Max is doing the final pre-flight checks in the avionics bay.
Yeah, so I just had a sorry, go ahead, finish off.
I'm just connecting the batteries. So as soon as I do this, we hear confirmation beeping and the system gets live.
As you might have noticed, the aircraft is beeping, motors are slightly spinning, but it's completely safe for me to sit even in this position that close to the motors, because aircraft has a double redundancy fail-safe system for arming, so there is absolutely no chance that it will start spinning up the motors as I'm sitting next to it before we will command it to do so from either the controller or through our GCS. So here I just carry out a quick glance at all the avionics, make sure that all the connectors are securely in place, nothing has been disconnected during handling of the aircraft, so we are perfectly safe to carry on flight.
GPS gives the green light. It means that the lock has been established and we are all good to go. So basically, as you can see, all the setup takes less than just a few minutes.
And now we're going to carry out just the final checks before takeoff. So I'll start off with checking that the wings have been attached correctly, that those indicators are up. I cannot take the wing off. Same with the rear V-tail, it's securely in place, very sturdy. Then we're going to check the rear of the aircraft. I've checked the V-tail. Here I'm going to check the motor, make sure there is no play in the propeller, that the rear nuts are securely tightened, and we can see as we're tilting the aircraft that the rear V-tail is starting to pitch the aircraft forward, meaning that the avionics have powered up and aircraft stabilization system is working. I've checked the rear motor, make sure there is no play in it. They are new props, we have changed them since coming back from the drone show, as people may have been touching them and something could have gone wrong, so they're new set of props ready for flight test now. Now we're going forward to the main wing. We start off by checking the leading edge, the wing tip, the rear of the wing, make sure there are no marks that might have happened during transportation or setting up the aircraft. Make sure everything is nice, smooth, give it a nice little rub on the top. everything seems perfect. We check once again just with power of fingers the tightness of the two screws that hold the leg together. They are torqued up to a specific setting. We're just doing a finger check just to make sure. It's never wrong to be too safe. After this, we're checking underneath the wing. So if you could maybe come closer here to see. So each wing has, on this model, it has one aileron and it has one servo. Oh, where are you? There you are. So here, servo. Servo has the actual servo motor inside of the wing, and then it has the rod which is connected to the actual aileron on the side of the wing. And we're checking the tightness of the two bolts that are holding the rod together. Make sure there is no play in it, and yeah, everything's ready. We do the same check on the other side of the aircraft. As you might have noticed, if you'll just show the top of the wing. So this is actually one of our oldest aircraft and serves as a great test bed that has proven its worth in time. And you can see some marks, some small dents, but it really shows that well, this aircraft is nearly 5 years old, 4.5 years old, for an aircraft that has approximately 280 flight hours. You can see still in what great condition it is, and we are very proud to still carry on showcasing this aircraft because it really shows to customers well, the reliability of the aircraft. So
the final thing would be to position that into the starting takeoff direction.
Yep.
So let's lift it up.
Yep, I'll just finish off with the props. So I'm checking once again here that props have not been moved just a little bit. The markings are still in place from setting it up. As I said, they are a new set of props, so no need to worry about the quality of them. We check that the bottom hatch is locked in. Front one, that all the indicators are locked in. PTO tube is securely screwed in. We're good to go.
Cool. Yep. Let's position that 108 degrees.
Yep.
Yeah, that looks good. Okay. So now let's go to the computer. So we have the setup and the radio connected here. So as you can see, it's pretty simple. That's for the compliance for the manual control. We'll do semi-manual takeoff here because the space is quite confined, and then we'll set it to full autonomous flight mode. So we can see that the aircraft is ready, passed all the checks. We confirmed the flight mode, and now we are in Q stop. So Max will go over there closer to the aircraft and will explain the rapid takeoff and rapid transition. So it should take less than 15 seconds between the aircraft is taken off and that's in fixed wing flight mode. And this allows us to save a lot of time in hovering and hence save the battery, which means that we can fly longer and more time in fixed wing mode.
Yep. So I'll just take over that control. Stand nice and clear of the aircraft for safety. So as Kirill has mentioned, here's our mission that we're going to execute afterwards. But for now, let's enjoy the beautiful takeoff.
Okay, arming in 3, 2, 1.
Clear up and above. And now the aircraft has switched off the hover motors and is in complete fixed wing mode. Now, many people have been asking about the props, if they align once the hover motors stop spinning. As you can see, 3 of them have aligned, 1 of them isn't. This is because our motors, they do not have a specialized magnet which does this. But as you can see, the wind is doing its job and aligning them by itself. So now the aircraft is completely...
As you can see, I'm just here, so we did just the manual takeoff to make sure we clear all the obstacles because that's quite confined space. But now the aircraft is flying full autonomously, so we have a simple mission which is about 450 meters. So it's less than 500, making sure that we stay velocity compliant. And the setup is just here on the table. You can see it's pretty compact and simple, easy to use. So this is the ground control station with the flight path, and the aircraft is flying just over there. Altitude 120 meters.
So you can see the altitude is 120 meters. We are 280 meters away from the takeoff location, and we're doing a nice loop around. So aircraft is traveling at a constant of 22-23 meters per second, of course, giving the variation for the wind. Today's a really nice day, actually. No wind, no rain, so
It's not ideal from the cloud perspective, but the cloud space is still high enough to conduct the visual flights. Of course, we could also do that fully autonomously going into the clouds or above the clouds if you have special clearance. But in terms of winds, it's pretty nice. In terms of the IP protection, it's also good because you can see it's a bit misty at the moment, but the aircraft handles that perfectly. No any issues at all. And this configuration can go for up to 2 hours, 20 minutes flight time. So you can see from here the flight speed is about 22 meters per second, which is equivalent to about 80 kilometers an hour, meaning that in 2 hours it can cover something very close to 200 kilometers. And that's the distance. So as far as we are speaking, the aircraft already covered 3.5 kilometers in just 2 minutes 30 seconds. So it's pretty impressive. You can see also the consistency between the flight paths, meaning that the flight control system handles that perfectly. So the lines are ideal, and even if we zoom in, we can see how accurate it follows the previous flight paths. So on the next leg, we will take it back into the semi-autonomous mode or semi-manual mode, whatever we want, and demonstrate to you some of the safety features. So that basically includes the low altitude approach, in which if we have the aircraft going too low, it enables the main props to make sure it has generating additional lift, so it just doesn't go too close to the ground. That's going to be the first test, and the second test is going to be stall. So we'll bring that to about 15-16 meters per second flight speed, and we'll see that it will just about going to stall, but then it will enable the main props and save the situation. So these are two safety features which are always enabled for our customers. Of course, that can be disabled, but then that's going to be a safety problem. But basically, it saves an aircraft in case something goes wrong.
excellent.
So
Let's take it over.
Yeah, just about to go right here. So what I'm doing now, I'm just engaging the fly-by-wire A mode. It means that it's kind of like maintaining zero roll pitch angles, but at the same time, you can introduce the manual control. So it's fly-by-wire, I have manual control. I'm reducing the thrust a little bit.
So let's do a lower pass to show the viewers the altitude.
Yeah, so now we are about 90 meters and the assistance altitude is about 60 meters. So we'll go lower on this leg and you will hear that at some point the main props will kick in. It means that we are too low and it's trying to save it. It should do that just about now. Yeah, you saw that. So it was just going into that hill and the altitude was a bit too low. So it enabled the main props.
And
save the
no
situation.
switches were flicked.
No switches at all. And then just to go back into normal flight mode, we enable thrust, getting some altitude, and then the main props will disable again. And by the silence of the main props, you can hear that they were just disabled. So the next test is going to be about the stall speed. So what I'm going to do, I will pass around ourselves just right here and try to reduce the power and pitch up. And in that case, normally the aircraft would stall, which will lead to spin or a rapid lose of altitude. But in this situation, the aircraft will just go into hover mode and save the situation. So let's have a look around. So that's a nice approach. Reducing the power, pushing up. You can see the airspeed drops, and you can see the main props kick in. So it saved the stall.
So here you can see that the horizontal speed is 10 meters per second. And once again, no switches were flicked.
No switches.
So we are
Almost
still
nothing.
in fixed wing mode.
To continue flight, we just add more thrust, continue the turn. You can hear that the main props got away, and we are back into normal flight mode and fixed wing.
I've lost the aircraft. Come on, focus. Thank you.
And just to make sure that a bit more fun, we can show you high-speed approach. That's my favorite one. For that reason, we actually should disable the Q assist for the altitude. Otherwise, it will violate that and doesn't allow me to do that. So that's not recommended for the pilots or the clients who use the aircraft. But for us as the developers, we can do that. So I'll put that for a while into the auto mode. So it just gives me a bit of time to set up in the settings.
So you can see now the aircraft is
I
going
can
to
just,
join the closest waypoint.
Put the transmitter here on the table, so I'm not controlling that at all. Just does all automatically. And what I'm doing, just setting the QSC's altitude to, let's say, 5 meters. Done. And then that will allow us to go a bit lower.
Just to make sure that all the compliance is met, we are showing you this nice little live demo, but we do have an indicator here who is constantly looking out for aircraft and any other dangers that might happen. So, of course, all safety first.
So I'm going into fly-by-wire mode, controlling that semi-manually, losing a bit of the altitude on the slag. Now we can start, it's ready. That's pushing the airspeed to the maximum, which is about 40 meters per second, and that's about 140 kilometers an hour. Pretty impressive.
So let's just accelerate there, so I'll show the screen. Yeah, if you'll accelerate.
Okay, working on the next approach. Sounds like fun.
So the aircraft has went past us at about 35 meters per second.
As the next step, we can also show the rapid descent capability. So once the aircraft is quite high enough and that you need to lose the altitude quickly to not to waste the battery, basically. So we can go into the rapid descent mode. So it's important to position the aircraft into the wind direction. So it's going to be helping with that. And all we have to do is, again, just going into hover mode. So now it's a turn.
As you can see, the pusher has stopped spinning, and now we're going to do a rapid descent. I'll zoom out so that you can see aircraft going down.
And now it's disarmed. So we're in flight for 10 minutes. We traveled almost 14 kilometers, and we used just 12% of the battery, which is quite impressive. It's getting quite rainy, so just probably
Oh, that was good timing to start.
Very good timing. Yeah, we'll just do a few final walk-arounds. So you can see the aircraft, rain is not a problem at all, so everything looks good. Just to mention again, that's the actual aircraft which is used for the partnership with NHS in Kent, down in the southeast England, for transportation of the pathologists. And as you can see, that this innovation basically allows to hopefully save lives in the nearest future. We, SkyDrones, and the whole team are proud to be partners and driving this innovation forward. And many thanks again also to Innovate UK, who support various activities. And over to you, Max. just to say a few final
Thank
words,
you.
because
Yeah,
you are
so
the
I'll
project
behind the
manager
camera.
for this project.
Yeah, absolutely. So actually, as of earlier on today, we have sent off the final report on the integration of the bespoke drone design, which is the integration of the bottom cargo bay, or well, better to say, we have adapted it to meet the needs of the NHS and of course the UN 3373 standard regulations. I'll try to cut this short. Yes, so we have now passed halfway through the project. It's going perfectly on track. Aircraft is now going into some final checks for testing the temperature controlled environment, vibrations, make sure that the samples are not being damaged or spilled during the transportation. Of course, for now, this, as you have seen, this is a working prototype. We're very proud to show you as it is, not polished up version. I think that's very important to show the reliability and honesty of our company. Yeah. So after this, we'll go into the manufacturing of the real working version for the transportation of the medical goods, which is expected to, we can publish it approximately mid-October. Actually, you have probably seen the post that we posted just this morning regarding some of our achievements this month, and also we're also very proud to announce that not only we're on a very good front with the national health service provider, we're also going into Canada, where we'll be taking on clients such as for healthcare, defense clients, as well as oil and gas and agriculture. So definitely look out for our new post. And to anyone who's in North America, in Canada specifically, we'll be in Canada from 19th to 25th of October in Toronto. We're more than happy to travel around locally, or if you want to come in and say hi to us and speak to us, please do reach out to myself, Kirill, SkyDrones, anyone from our team, and we'll make sure to arrange this meeting.
Thanks for watching. It's getting pretty rainy here in our location, and I think it's the right time to go inside and have some drinks.
Definitely.
To celebrate this and warm up a little bit. So thanks for watching.
Thank you very much for watching.
See you in next videos. Stay tuned.
Stay tuned.
And we'll go inside.
Let's go.
Let's go back.